AliCamp 2024. Sarah Federman, From Screen to Speech, A Screen Reader Journey. AliCamp 2024 is brought to you by our gold sponsors Intopia and ANZ, our silver sponsor Canva, and Auslan sponsor SignHow.
Okay, hello, I'm Sarah, not Adrian Rosselli. Sorry, easy mistake, I know, but I did just get my hair did, so. I work as an engineer on the accessibility innovation team at Canva, where we are focused on building accessibility features, making the Canva editor accessible, and making the content produced in Canva accessible. We still have a long ways to go, but we have been learning a lot along the way. This is a little bit of a technical talk, so there will be some level of assumed knowledge. Bear with me. I'll try my best. So, when I moved from working on design systems into working on accessibility full-time, it became pretty obvious to me that my understanding of building accessible software had some holes. And part of that was because I hadn't really contextualized a lot about assistive technology. I had only learned a bunch of rules and a lot of do's and don'ts, and I think in part that's due to a lot of accessibility educational content being that way, with like a lot of checklists and criteria and all that stuff. Personally, my ADHD brain is a sieve. I can only ever remember information based on systems thinking and mental models. Basically, I never grew out of saying, but why, in response to everything. I don't find simplifying things and making them more approachable necessarily makes it easier for me to understand. But if I can build my mental model, then I can grasp far more complexity. So, a while back, I put out an ask to some of our engineers that I work with to tell me, what do you want to learn? And one of the answers I got was, for me, it's how do ARIA tags translate into screen reader announcements? How does the browser make sense of potentially wild and weird DOM? And it wasn't the first time that I've been asked that at Canva, where folks have brought up that they have trouble contextualizing how screen readers actually work, or what using a screen reader means in practice. So I want to dive a little bit into that today. I actually want to start with understanding how screen readers interact with desktop applications, because it's a bit simpler and we can actually build on that understanding. So this is a lovely example of a Windows desktop application. It's a very old screenshot of Microsoft Outlook. We've got our toolbars and our inboxes and an outbox, which I've never understood. I think it's like peak Windows XP, beautiful. There's a lot of stuff here. So how does screen reader software actually get access to all that info? So every operating system has their own version of an accessibility API, which people building software clients, like screen readers, can use to hook into and get information about user interfaces. Those APIs aren't exclusive to accessibility either. They're also used by like testing apps and stuff. Some of the more common ones include Apple's OS X accessibility protocol and Windows UI automation. Also, please take this with a grain of salt. I'm not a native app developer. I'm just weirdly dedicated to reading documentation. Not sure how I ended up in accessibility. So these accessibility APIs expose a tree that clients can navigate to get information about what's on the screen. The desktop is our root tree node, and every app window creates a subtree, which contains the content and the controls shown by that app. Each node of these trees represents a part of the UI. Elements have a single control type, which defines what the developer must support, including properties and control patterns like scrolling, selection, or toggling. They also create and respond to specific events, and they adhere to a specific structure in the tree. On the right here, I have some examples of native control types. The first is Windows, the second is OS X. They're pretty similar, but a little different. For example, like the Windows one has a data grid, and Apple has just grid. But they both have like a menu and a menu bar and buttons, so we can get to where we need to go. So an example of one of these control types is a tab and a tab item. What Windows UI automation specifically exposes is two different views of our tree. One that includes all the items that contribute to the logical structure of the UI, and one that only includes the relevant info required for a user to take an action. So we have a tab, and in the control view, our tab can own tab items. It also could have a scroll bar, either one or two, because you can go horizontal or vertical. And then that scroll bar has either no buttons because it's disabled, or two, which is our up and down. The content view doesn't care about any of that. We just got a tab and it owns tab items. In the control view for a tab item, we have a tab can own either an image, text, or a pane, and a pane can have a bunch of stuff inside of it. In the content view, you don't action an image or text, so we only have our tab item and its pane. Tabs have to follow a few patterns. So for selection includes always needing a tab to be selected, and only one tab can be selected at a time. Clicking on a tab can only select the tab. It can't invoke an action like a button. This is in contrast to something like the menu pattern, which has no selection, and each item issues an action. So far we have our basic model where we have an application. That application generates an accessibility tree. That tree is read by assistive technology, and our user is interacting with that assistive technology. In practice, that might mean we have like a theoretical app here that includes a few buttons, one of which is a refresh button. That button is represented by a node on the accessibility tree. A screen reader like VoiceOver visits that node and then announces refresh button to the user. The user then tells VoiceOver to press the button, and VoiceOver calls the accessibility API method accessibility perform press on that node. That then generates a click event on the node's associated UI element, and the application can decide what to do after that click. In this case, it'd probably refresh the screen. So that's the basic model for how screen readers interact with applications on your computer, and that's all well and good, but I build things for the web. Most of you all probably do too. So on the web, it's basically the same idea, but our flowchart just gets a bit bigger. Instead of the desktop application generating our accessibility tree is now a web browser. But for the web, the only content we really care about is what's on the web page, not like the toolbars and the menus and the stuff that's part of the browser UI around the web page. On the web, we use HTML to describe our page contents, and then the browser uses that to generate our DOM tree, which we can then read and modify via JavaScript. Once we've generated a DOM tree, we use that to decide what is visually rendered, but it's also separately used to create our accessibility tree. So I want to zoom in a little bit on how the DOM gets translated into that accessibility tree. So let's take a typical slice of HTML here. We have an image tag. It's got an src and an alt attribute. That's then painted onto the picture, onto the page, which is a picture of bees swarming. Our image is separately represented in the accessibility tree as a node with a role of image and a name of bees swarming. It's also worth remembering that the accessibility tree is often the only representation of the content that assistive technology has access to, so it's worth making sure your visuals actually match up to your tree nodes. For example, if we had like a button that says go, but we put an ARIA label on it that says submit for whatever reason, that will actually completely replace the go in the tree, which it's not ideal for a screen reader user, but they could probably still use the form, whereas a voice control user might get confused because they just told their software to press the go button based on what they saw on the screen, and their software is like, mate, there's only a submit button here. I don't know what you're talking about. So here's an second example. On the left, we have a tree starting with a document body with an H1 heading that says sign in, a text input named username, and an input with type of submit. On the right is that DOM tree translated to the accessibility tree. But how did we actually get that accessibility tree? How did we get from an alt attribute to the name, or input type equals submit to a button? Well, the accessibility tree is actually using the ARIA roles, names, and properties, not HTML tags and attributes. And that brings us to ARIA. And yes, folks like to say the first rule of ARIA is don't use ARIA. What they really mean is don't use ARIA unless you need to, but also maybe make sure you understand what your ARIA is meant to be doing. So we already know that Microsoft and Apple have their own ideas of what UI elements can be and how they're named and how they should work in the accessibility tree. The ARIA technical spec is basically the web's version of this. It's universal because the web is not specific to Apples or Windows. ARIA is actually a suite of separate documents. There's a few of them. It's not just one. The ARIA technical spec includes the universal definitions of those roles and properties, but other ARIA documents cover how it should be mapped. So starting on the left, we have an HTML box, and then that HTML is translated to our web accessibility tree, and that's the one that has those ARIA roles. The way that that's translated is described by the spec called HTML ARIA, or HTML accessibility API mappings. And that's one document of ARIA. Then there's the name and computational one. Don't worry about it. Once we have our web accessibility tree, we need to take it and make it into that native core one that's used by Windows or Apple. And that's done by using the core accessibility API mappings doc, which shows you how all that should work. The spec also notes how that HTML should be translated into ARIA, so that's that first doc. So many native HTML elements, like that image tag we looked at earlier, by default have an ARIA role attached. So going back to that example, that will be mapped to an image ARIA role. But say, for example, we'd left the alt tag as an empty string to mark it as decorative. In that case, the HTML would be translated to a presentation ARIA role instead. If we had just omitted that alt attribute entirely, it would show up as an unlabeled image role, which we basically never want. So that's how we calculate what ends up as the accessibility tree node in the browser. Once we have that, we use the core mappings on the right here, which says the image HTML tag becomes an image ARIA role, and that ARIA role is then translated to an image control type for Windows, or an AX image for OXX. I never can say that right, sorry. Apple. If you're starting to think like, well, hang on, that's like, there's the code we as developers write, then there's that browser interpretation of HTML into DOM, into ARIA, then there's the ARIA mapping to various native APIs, and then there's the way that screen readers access and interpret that information. That's a lot of layers that can introduce inconsistencies and bugs. And yes, you're absolutely correct. Accessibility is actually pretty hard. Don't believe anyone that tells you otherwise. They're probably trying to sell you something. In addition to those bugs, often browsers or screen readers haven't implemented support for some of the spec, or they've interpreted it differently than some other software. These sort of situations are why it's really important we test in different browsers and different screen readers. The part you may have heard about ARIA previously is that it adds more semantics on top of HTML so that we can support fancy things like combo boxes and tree grids. That's one way to think about it, but the way that I think about it is ARIA allows us to bridge the gap between what UI is available in HTML on the web and what UI is available for building native apps. So those native accessibility APIs, like NS Accessibility, that's the Apple one, or UIA, support a much larger range of UI elements than just HTML. Those native accessibility APIs support a larger range of elements, and then ARIA allows us to add information to our HTML to say that instead of using whatever this HTML element is originally, like an image being an image role, we can say, let's use the native version, so let's make it a menu instead, which please don't do that, but regardless. Here's an example of that where we needed to create a custom checkbox styling, so we had to use a div. Dreaded div, I know. By default, divs don't really have a role. Generic doesn't count. So we override that and we add a checkbox role. What's shown in the accessibility tree here is equivalent to what would be shown if we'd used an input type equals checkbox. They're exactly the same. But remember how we talked about how each control type is also expected to implement certain interaction patterns? When we use ARIA this way, That's now our problem. We have to do that via JavaScript, and that is where a lot of bugs come from if we fail to do that correctly. If you ever want to see how a website gets translated into a tree, we can view a version of that in our DevTools. This one's in Chrome. The same way that we can inspect the style and elements, we can check what the accessibility node looks like. This can be really helpful for debugging and making sure that you actually have in your tree what you intended. It's not always 100% accurate, but it is a really helpful tool. If you're curious, you can even go a step further and look at the native ones, but I'm not going to go into that today. So we've covered how the DOM uses ARIA to translate an accessibility tree for the operating system, but how is that actually used by screen readers? So we'll zoom in on this part here, which is where the accessibility tree is read by screen readers, which is users are interacting with their screen readers. So let's revisit how the accessibility tree can be presented. On the left, we have a combo box, and that combo box has item 1, 2, and 3, with item 1 currently selected. We know that we get a control view and a content view in Windows. In the control view, it tells us everything that's on the page. So we know we have item 1 currently selected. There's a list. There's 3 items in that list, item 1, item 2, and item 3. There's a button that has a drop-down. If we're just trying to pick something from this menu select thing, combo box, all we need to know is what's currently selected and what our options are. So we can also think about the 2 views as one is best for consuming the UI content, and the other one gives us what we need to interact with the content. The Windows-based screen readers actually operate on a pretty similar model. They're always reading from the accessibility tree, but when it comes to how the user interacts with the screen reader, there are 2 modes. The first mode, which is the one for consuming content, is often referred to browse mode. In this mode, the screen reader reads our accessibility tree and creates a flattened copy of the web page, essentially. We read the content by moving our virtual cursor around this copy using arrow keys and single letter shortcuts, like using H to jump to the next heading. You can think of moving the virtual cursor as sort of like moving your eyes around on a page without actually moving your mouse or your keyboard focus. When we want to interact with an element that our virtual cursor is pointing to, the screen reader calls those native APIs that we talked about earlier, like accessibility perform press. This flattened document is mostly invisible to the user, but good to be aware of as developers. The second mode, focus mode, is used when we are tabbing to elements with an interactive ARIA role. We know that many ARIA roles have a keyboard pattern that they follow, like using arrow keys to move a slider around, and that interaction is built into the HTML input or handled using JavaScript if you're making your own. When we tab to that slider, we stop using our flattened copy of the document, and we send our key presses directly to the browser, the same way that we would if our screen reader was just turned off. So, for instance, if you press the Enter key in the browse mode, often we'll use the accessibility API to generate a click event instead of like a key press. If you're in focus mode, that's just a key press event, and then our keyboard event listeners in JavaScript would be able to pick that up. Wrapping up. So, given this new understanding, what might we do differently? Well, we would first consider how our web UI would map to native UI when choosing our ARIA roles. So if we've got like a list of buttons, does it function like a menu, or is it just a list of buttons? Does it map to that native idea of what a menu is? If we're building tabs, we know tabs can't do actions, so we probably wouldn't just shove a button that does stuff at the end of our tab list. We might use the accessibility tree and our understanding of ARIA mapping to debug when screen reader announcements aren't the ones you expect. And we might also use that accessibility tree as an extra data point to validate our assumptions. So like recently I wanted to double check that something was being hidden with visibility hidden, and I was pretty sure that didn't work. And I checked the dev tools, and lo and behold, it was completely gone from the accessibility tree. So we changed that. The other thing is understanding how your components will be impacted by those screen reader modes. So focus and browse mode. Adding an ARIA lab to a wrapper div around a menu option isn't really going to help us, because in focus mode, we only ever announce what has focus, and we don't focus the wrappers, we focus the options inside the menu. Conversely, if we consider that in browse mode, we are using a copy of the document, using JavaScript to change ARIA properties that aren't meant to hold state, like our ARIA labels, might not actually update our copy. So it wouldn't get announced at all, really. It's just happening and not getting picked up by that virtual buffer. So just a quick recap. No, that's a lot, sorry, to shove into 20 minutes. Or the next one where I go over. So as a quick recap, we chatted about how software accesses info about UI using those native accessibility APIs, and then those APIs expose an accessibility tree. In the browser, the tree is generated via HTML and DOM, and uses ARIA to map that back to the native APIs. A user operates the screen reader by using their keyboard, which either announces from a flattened version of the document, or their key presses are routed directly back to the browser, depending on what type of control we're on. And that is screen readers.
AliCamp 2024.